Okay, here we go. Measurement, sections 1.5 through 1.6. We've used measurement all our lives. We've either used inches or centimeters or millimeters using a ruler. Have a car and we know how much pounds are, or kilograms, or tons. We can put volumes of gas in our car by gallons or liters, and we can drive the car in kilometers per hour or miles per hour. But what we do need to know is, in science, we don't use the English system. We use what we call the metric system. It's also known as the SI units, or the System International. Why use the metric system? I mean, all of us know the English system, right? Well, I don't think you do. How many pounds are there in a ton? How many inches are there in a mile? It gets really complicated because they didn't use the same unit each time. The metric system is advantaged because it's based on unit 10. So every unit is either 10 times more or 10 times less. Well, or 10 in it. Everything is 10. If you remember that for the English system, it's 10. So if you look at this chart that's in your book, you can sort of see what I was telling you. The base meter in the metric system is 1 meter. A larger unit, a kilometer, is 1,000 meters. Smaller units, 10 decimeters is 1 meter, 100 centimeters is 1 meter, 1,000 millimeters. It's all based on 10. But when you get to the English system, 1 yard is the base unit. The larger units are a mile, which is 1,760 yards. There's 3 feet in a yard and 36 inches in 1 yard. There's no rhyme or reason to why. Another advantage of the metric system is that it has the same prefixes throughout. Doesn't matter if I'm measuring volume, if I'm measuring length, if I'm measuring mass, the prefixes are the same, so I can memorize the prefix and I know how many times the base unit it is. So for instance, mega, capital M, is 1,000,000 times the base unit, or 10 to the 6 times the base unit. Kilo is always 1,000 times the base unit in a small k. Deci is D, it's 1/10. Centi is 1/100th. Milli is 1,000th, and so on. These right here that are listed, these are the ones we're going to be using the most, and you really need to memorize them and become very familiar with them, especially if you're going on to nursing and things like that, because these become very helpful in what you're going to be doing and how you're going to be diluting or doing things like that. Okay, so we have our basic units. They are length in meters, mass in grams, and time in seconds. Okay, so to get area, we've got an area that we want to find of a rectangle. We would go length, we'll use an L, times the width of our W. Okay, so for volume, like for the volume of this red cube, we still have the length and width to find area, L and W, but now we have a height. So we're going to take length times width times height, and we would be able to find the volume. So these are known as derived units. You need to be able to do simple problems to find the length, to be able to find the area of something, and to be able to find the volume of something. Let's go on a little bit more. Okay, temperature is also one that we need to worry about. We're used to seeing Fahrenheit. 32 degrees is where water freezes, 212 is where water boils on the Fahrenheit scale. However, we want to move it into metric, and metric is Celsius. Sometimes you'll hear it said centigrade. It breaks the temperature scale down in even increments between 0 and where water boils. So you've got 100 degrees between the two. 0 is where it freezes, 100 is where it boils. And a negative 273 degrees Celsius is absolute 0. You'll notice on the Fahrenheit scale it's 459, which is an odd number, or a weird number, but so is, I guess, 273. Now, we'll need to know how to get from Celsius to Kelvin. A Kelvin scale is used as we get into gas laws and things like that, because we can't have any negatives. And you'll notice both the Fahrenheit and the Celsius scale have negatives. So we need to be able to convert from the Celsius to the Kelvin scale for our gas laws. These two equations over here on the right are really important. These two let you go back and forth between Fahrenheit and Celsius. Now I wouldn't necessarily memorize both of them. I'd memorize one of them. Pick the one that's easiest for you. For me, the bottom one's easiest, so I would memorize it. Then I can solve for C and get the top one. Not a big deal. But I go back and forth using this equation from Celsius to Fahrenheit. Now I would also choose just one of the bottom two equations. Again, I like the bottom one. So the bottom one on both of them is what the ones I would memorize. It's really easy to get the one on the top. You've got to memorize these. There will be problems on the test where you will need these equations and you will not be given them. So make sure that you can go back and forth. This is really important, especially when you're working with patient care, so that you know where a person's temperature is supposed to be and where it's not supposed to be, how many degrees off are they in danger. You will be using the centigrade or Celsius scale. You will not be using Fahrenheit, so you need to make sure that you can go back and forth. Okay, heat energy is also something that we need to talk about. Heat energy is measured as a derived unit. It is joule or calorie. You probably have heard of calorie. Now this isn't the kind of calorie that you count. There's actually 1,000 of these lab calories in a kilocalorie. And we would write 1,000 calories is equal to 1, and we use a capital K, or capital C for calorie. Okay, so here we've got a cereal side that has the nutritional facts on it. And you'll notice right here is the cereal calories. Those are kilocalories. That means you take that number and you times it by 1,000, so there are actually this many lab calories in there, or regular calories. Now our body does need kilocalories. It needs a lot of energy to get it going. So if you were to only have 220 lab calories, you wouldn't be having very much energy to get going anywhere. Okay, this page, number 17, this table, commonly used metric units, is going to be your friend for the first little while until you get used to figuring out how to convert back and forth and do what you need to do. So please make sure you mark it or put a tabby on it or something so that you can come and find it quickly. Once you get used to this and going back and forth, I think you'll be just fine without it, but right now I think this is a good thing to make sure that you become familiar with. Okay, so as you do sections 1.5 and 1.6, there are some examples in there, and I would encourage you to go back and look at those examples so that when you come to class that you can be able to do those problems. Just a reminder that you need to make sure that you're watching carefully your math, and we'll talk about those in previous units. Okay, that's the end of 1.5, 1.6, and we'll see you in class.